Hello, friends. Welcome back once again, and thank you for tuning in. In the last session, we looked at how to rationalize the denominator of a fraction whose denominator is a surd. And what we looked at were cases where the denominator had a single surd, what we call monomial surd. Now today, or in this session, I want us to look at how to rationalize the denominator of a fraction whose denominator has a binomial surd, or a surd in two terms. For example, an example of a surd whose denominator has a binomial surd is like what we have here. Like one, we could talk about like if we have a surd like we have 2 over root 2 plus root 3. That's an example of a fraction whose denominator has a binomial surd. Another example could be like even a surd like what we have here. Let's say 1 over 2 plus root 5. This is another example of a fraction with the denominator having binomial surd. Now, even though here we have a rational added to a surd, we call this binomial, a binomial surd. We could also talk about, for instance, a surd like, let's say, root 5 minus, let's say, root 2 over something like root 7, even minus root 11. These are all examples of fractions whose denominators have binomial surds. Now, how do we go about this? Now, let's look at the first case. For instance, we could be asked to rationalize the denominator of this surd, 2 over root 2 plus root 3. Now, in this case, we take the surd, the fraction that is 2 root 2 plus root 3. Remember, as we emphasized in the previous case of rationalization of denominator, again, our focus will be in the denominator. So we come here and check and ask ourselves, what do we have in the denominator? Now let's look at what we have here. We have two terms in the denominator. Can we consider the effect of having the same surds in a different bracket, but now the difference will be in this other bracket. Instead of having a plus, we have a minus, like what we have here. So here we have, and multiply the denominator by that other surd. So we have root 2 minus root 3. And what is done in the denominator must also be done in the numerator. So we are multiplying the denominator by 2 root 2 minus root 3. Remember, how do we get this? We consider the surd that we have here, root 2 plus root 3. We have the same terms, root 2 and root 3, the only difference being the minus. So in the numerator also we'll have root 2 minus root 3. Then perform the multiplication. Okay. Now, from our quadratics, if you're keen enough, you'll realize that when you have such brackets, it reminds us of one of the quadratic identities. Remember the quadratic identities, we said that if we have, for instance, let me just remind you, a plus b multiplied by a minus b, the result will be a squared minus b squared. If you expand, which you are referring to a difference of two squares. So if you have a squared minus b squared, now in factorized form, you'll have two brackets with the same letters a and b. The only difference will be one bracket will have a minus, another bracket will have a plus. So using that, we can work out what we have here in the denominator. Remember, the numerator will still have our 2 into root 2 minus root 3. Now, in the denominator, we'll have root 2 squared minus root 3 squared. That is from our argument of difference of two squares as learned in algebra, specifically quadratics. Now you can as well go through the long process of multiplying this one by the two terms in this bracket and then adding to root 3 by the two terms in this bracket. You work out, you'll get the same result as simply squaring root 2 and then subtracting the square of root 3. Now in this case, what we'll have, when you work out up there, we'll have 2, the numerator will be 2 root 2 minus 2 root 3 over root 2 squared is 2 and root 3 squared is 3. And this leaves us with 2 root 2 minus 2 root 3 over negative 1. Remember, now we have a rational number in the denominator. The denominator has been rationalized. And of course, we can work this out and we have 2 root 3 minus 2 root 2 because we divide by negative 1. So what in the numerator was negative becomes positive and what was positive becomes negative. This is the answer. Now this we can write over 1, but whenever the denominator is 1, it is needless to write that 1. So this is our answer, the rationalized form of the denominator of the fraction 2 over root 2 plus root 3. If we consider the other, we may consider the other. Remember, we had those three examples of stats. Consider the other. Could be asked to rationalize. Let's look at that second example. Rationalize root 5 minus root 2, everything over, remember, root 7 minus root 11. Root 7 minus root 11. Minus root 11, sorry, this is root 11. You are asked to rationalize. In other words, rewrite the fraction such that we only have a rational number or we do not have a third in the denominator. Again, as we said, the focus is in the denominator. So what do we have here? Now let's consider the effect of multiplying the denominator by root 7 minus, now in this case it will be plus. If it was minus, we take the opposite, plus root 11. And what is used to multiply the denominator must be used to multiply the numerator. So we have root 7 plus root 11. Okay, so this reduces to, now remember, in our numerator we'll have, as we would multiply quadratics in algebra, so we have root 5 multiplied by that bracket, root 7 plus root 11, then minus root 2. Remember this root 2, it's a minus, multiplied by the same bracket, root 7 plus root 11. Now in the denominator, using our quadratic identities, this will be the same as root 7 squared minus root 11 squared. And what does this reduce to? So when you open the bracket up there, we have root 5 multiplied by root 7. Remember, the order is the same of the surds, so we can multiply the numbers under this, the radicals. So that is root 35, then plus root 55, then minus, must take care of the negative, root 2 multiplied by root 7, that gives us root 14, then minus root 2 multiplied by root 11. What is that? Correct, you're right, that is minus root 22. Now in the denominator we have root 7 squared, which is 7, minus root 11 squared, which is 11. And that leaves us with, now in the numerator, can we simplify it more than this? Do we have similar surds in the numerator so that we can collect like terms? No, we don't. So we'll just have our root 35 plus root 55 minus root 14 minus root 22 over negative 4. Now you may leave it this way, or you can work out with the negative so that you only have positive in the denominator. So that would mean that in the numerator we'll now have root 14, whatever is negative becomes positive, plus root 22 minus root 35 minus root 55. Now everything is over 4. So this is what we have as our rationalized denominator of the surd that we had, that is root 5 minus root 2 over root 7 minus root 11. When you rationalize the denominator, this is what it reduces to. Okay. Now, we have seen in these cases, both when we had a monomial and binomial surd, that when you multiply a surd, to change a surd into a rational number, like we were rationalizing the denominator, we were multiplying a given surd by another surd. Like when we had the monomials, you remember when you had a monomial of root 7 you multiplied it by root 7, then you are getting 7, which is a rational number. Now here you've looked at these two cases. For instance, we looked at root 2 root 2 plus root 3. Now when we multiplied by root 2 plus root 3 by root 2 minus root 3, we are getting 2 minus 3, which is -1, which is a rational number. Then we've also looked at another root 7 minus root 11. Then we multiplied it by another third, root 7 plus root 11. And here we got 7 minus 11, which gave us -4. Take note that our examples have given us negative. It doesn't mean that all the times we'll have negatives. It's just coincidental that these examples are giving negative. It's possible to multiply a third by a third and get a positive rational number. So take note of that. Now in this case, what we are saying that a third that is used to multiply another third and you get a rational number, like in these cases, is referred to as a conjugate third. Okay? So in this case, we call root 7 is the conjugate of root 7. So that when we multiply this by this, we get a rational number. 2 root 2 plus root 3 multiplied by root 2 minus root 3 gives us a rational number. So we say root 2 plus root 3 is the conjugate of root 2 minus root 3 and vice versa. That also means that root 2 minus root 3 is the conjugate of root 2 plus root 3. The same thing happens down here, or applies down here. So root 7 minus root 11 is the conjugate of root 7 plus root 11, and vice versa. That means that root 7 plus root 11 is also the conjugate of root 7 minus root 11, and the term is a conjugate. This is the spelling of the word conjugate. This is a third. This is a third that when multiplied by another third results into a rational number. By rational number, we mean a non-third number. So that's called a conjugate. Thank you so much for your audience, and I wish you well. And if there is any question, please go to the comment section and ask your question, and I will be glad to respond to it. And if you haven't subscribed, please do subscribe and share with your friends so that they may also benefit from this. Always take care. Love you so much. Bye-bye.